In topic 2, we're going to be looking at how to find the square roots and the cube roots of numbers using prime factorization. So remember from last topic, prime factorization is that list of prime numbers that multiply to equal the number. And we found the prime factorization by doing these factor trees. And then those last prime numbers we got were the prime factorization. So we're going to have to use those factor trees once again to get that prime factorization. But to start off, let's just quickly review perfect squares and perfect cubes. So remember, perfect squares are numbers such as 1, 4, 9, 16, 25, and they keep going and going and going. And those are perfect squares because we could take the square root of each of these numbers, so square root of 1, square root of 4, etc., and we will get a whole number as the result. Okay, so each of these numbers we can take the square root of and we will get a whole number as the result. And this is why they are perfect squares. Now we can also start with any number and we can square it and get a perfect square. So for instance, I could start with 6 and do 6 squared, which is equal to 36. And 36 would be a perfect square. Now we also have perfect cubes, and those are the ones where we could take the cube root of the number and get a whole number. So for instance, 1, 8, 27, 64, and so on are all perfect cubes. And the reason for that is we can take the third root of the number and get a whole number. So the third root of 8 gives us 2. The third root of 27 gives us 3. And the third root of 64 gives us 4. And there's an infinite amount of these, so these we can go on forever and ever and ever. Now we can also work backwards and start at the cube roots. So for instance, if we took 5 and we cubed it, we put it to the power of 3. That would equal 5 times 5 times 5 and would give us 125. And therefore 125 is a perfect cube, because if we took the cube root of it, we would get 5, a whole number. So now what we're going to look at in example 1 here is how to find the square root of a big number using prime factorization. So this will let us find the square root of this number without using a calculator. So to start off, let's find the prime factorization of 1296. So we're going to do our nice factor tree. Once again, we're going to put 1296 at the very top, and let's start breaking it down. So I'm going to do 2 times 648. 2 is a prime number, so I'm going to circle that. Then let's break up this 648 into 2 times 324. Circle that 2. Break up 324 into 2 times 162. And we're going to keep working our way down until we can't go anymore. So there we have our completed factor tree for 1296, and all those circled numbers are the prime factorization. Now the prime factorization, or PF, of 1296 is equal to, and let's look at all these circled prime numbers we have. So the simplified version of the prime factorization is 2 to the power of 4 times 3 to the power of 4, or we can write it out in the expanded form, which would be 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. And this expanded form here is actually going to help us out a little bit when looking for the square root. Now the next step we're going to do is we're going to group up all of these numbers in the prime factorization so that they're in 2 equal groups. And what I mean by that is each group has to have the same amount of each number. So to split those up here, I'm going to do 2 sets of brackets, and we need to place the same numbers and the same amount of those numbers in each set of brackets. So let's start with the 2's. So I'm going to do 1 2 in this bracket and another 2 in this one. Then I'm going to take this next 2, put it in the first bracket, and this next 2 in the other one. So now both of the groups have 2 2's that we used from the previous prime factorization. Now let's do the same thing with the 3's. So 1 3 goes there, and the other 3 goes here, and the last 3 goes here, and the last one goes over here. So now we ordered this prime factorization into 2 equal groups. Now let's continue solving this as if we were following BEDMAS. So we would solve everything in the brackets first. So let's do it. We would have 2 times 2 equals 4, times 3 equals 12, times another 3 equals 36. So we would have 36 in each bracket. 36 times 36. And this is how we find the square root, because what this is telling us is that 36 times 36 is equal to 1,296. And we could just rewrite that as the square root of 1,296 is equal to 36. And we're done. So the square root of 1,296 is 36. Now, I just want to point out that at this step here, we did 2 groups because we are looking for the square root. Square root, meaning we are finding 2 numbers that multiply to equal 1,296. So we did the square root, therefore 2 groups. And just so you know, this little triangle of dots I did here, that means therefore. And that's commonly used in math. So try to get used to that. It kind of saves us some time instead of writing the word therefore. Let's look at the next example here. Now this time we're going to be finding the cube root of a number. Cube root of 1,728 using prime factorization. So let's start by getting that prime factorization once again. So I'm going to start at the top of the tree with 1,728, and let's start breaking that down. So I did 2 times 864, circle that 2. Then I did 2 times 432, circle that 2, and we're going to keep going all the way down the tree. So here is my completed factor tree. I got all my prime factors circled, and now let's write down that prime factorization. So PF is equal to 2 to the power of 6 times 3 to the power of 3. And it's 2 to the power of 6 because we have 6 2's over here, if you count them all. And it's 3 to the power of 3 because we have 3 3's. So remember, the expanded form of the prime factorization actually helps us out here because we're going to have to group up these numbers. So I'm going to write out all the numbers here. We're going to have 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3. Now this time we're looking for the cube root. So instead of doing 2 groups, we're going to do 3 groups. So let's set up our brackets here. 1, 2, 3. And let's make 3 even groups. Let's split these numbers up into 3 even groups. So each group gets a 2, and I'm going to cross off 3 of them. 1, 2, 3, and each group gets a 2. Okay, and again, we can give each group another 2. And finally, we can give each group a 3. So now we split up that prime factorization into 3 equal groups. And if we write one more step here, we can see what the cube root of 1,728 is. So let's follow BEDMAS and solve everything in the brackets. 2 times 2 is 4, times 3 is 12. So we get 12 times 12 times 12. Therefore, and I'm using a little triangle of dots again, therefore, the cube root of 1,728 is equal to 12. And we're done. Now, example 3 is the exact same thing, except now it's an application of it. We can consider this like a word problem. So a cube has a volume of 4,913 inches cubed. What is the surface area of the cube? Now for this example here, it is a little bit of a tricky one and the number is pretty big. So I'll let us use our calculators for this one, and no, I will not give you one like this on your test. However, I might give you one with a smaller number where we don't have to use our calculator. Since it's a cube, what we need to understand here, so since it's a cube, we need to understand how to get the volume of a cube. So let's think about if we had a cube like this, how would we get the volume of it? Well, a cube, every side is the same length, right? So each side is length S, let's put. So the length, width, and height is S. Another way we can label these sides is length, width, and height, if you remember that. So the volume of a cube would be length times width times height. But since it's a cube, the length, the width, and the height are all the same size or the same length. So in other words, we could just put side times side times side, or S times S times S. And well, if three things that are the exact same are multiplying together, we could just write this as S cubed. So in other words, the volume, 4,913, is equal to the side cubed. So in order to find what the side length is, how would we get S all by itself? Well, we got to cancel out that little cubed there. How do we cancel that out? Well, we do the opposite of it. We're going to take the cubed root of both sides of the equal sign to keep it equal and balanced, and also to get that S all by itself. So if you use your calculator and do the cubed root of 4,913, you get 17, and that is equal to S, because this cubed root and this cubed cancel each other out. So another way we could say that is the side length is 17 inches. And this makes sense because if we put into our calculator 17 times 17 times 17, which is like the length, width, and height, we would get the volume, which is 4,913. Okay, so now that we have the side length, we need to find the surface area. So let's remember what surface area is. The surface area, or the SA, is the sum of the area of all the faces on the cube. And remember, a face is just these outside square sections. So like this here would be a face, and then on the top we would have another face, on the side we would have another face. Okay, so the surface area is the sum of the area of all the faces. So in a cube, there are 6 faces. So if we can find the area of one face, we can times it by 6 and get our answer. So area of one face is equal to, well, the area of a square is just side length by the side length, or in this case, it would be 17 times 17, which is equal to 289. So then the surface area would just be 6 times 289, or in other words, 1,734 inches squared. Now remember, for volume, it's inches cubed, okay? Because volume is a 3-dimensional thing. It is the amount of space that an object takes up. Whereas surface area is just the area of the 2-dimensional faces on the outsides of an object, which is why it is still squared.